Hello, dear student. Myself, Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan, District, Jalna. Today we will see course code number 302, paper number 16, numerical based on time varying field. Now, see first example. An inductor has inductance of 0.5 Henry and carries the current. The current is decreasing at a uniform rate of minus 0.05 ampere per second. Find the induced EMF in the circuit. Now, induced EMF is given by induced EMF equal to minus L di by dt. So, putting the value of here, L equal to 0.5 Henry and di by dt is here minus 0.05 ampere per second. So, putting this value, induced EMF equal to minus 0.5 into minus 0.05 equal to 0.025 volt. That is the induced EMF. Now, next example, that is a circuit consists of resistance 15 ohm, inductance of 5 Henry in series with battery of 20 volt. The current in the circuit is 2 ampere. This current is decreasing at the rate of 1 ampere per second. Find the potential difference across the series combination at this instant. So, the EMF across an inductor is induced EMF equal to minus L di by dt equal to minus 5 into minus 1. So, after simplification, induced EMF equal to 5 volt. Therefore, here potential difference across the series combination is given by V in series combination equal to VR plus VL plus A. So, here V equal to 2 into 15 plus 5 plus 20, that is equal to potential difference V equal to 55 volt. Now, next, calculate the mutual inductance of transformer in which output is 20 volt when current in primary changes at its rate of 5 ampere per second. Therefore, mutual inductance is given by M equal to minus induced EMF upon di by dt. So, M equal to minus 20 upon 5, that is 4 Henry. Now, in a car spark coil, EMF of 40 kilovolt is induced in the secondary when primary current changes from 4 ampere to 0 in 10 microseconds. Find the mutual inductance between primary and secondary winding of spark coil. The mutual inductance is given by M equal to minus induced EMF upon di by dt, and that is equal to minus 40,000 upon 4 upon 10 into 10 raised to minus 6 equal to 0.1 Henry. Now, next example, when a current through a coil changes at rate 0.2 ampere per second, an EMF of 5 millivolt is induced in it. Calculate the self-inductance of the coil. What will be the flux of magnetic induction associated with coil if current of 0.1 ampere pass through it? Now, in the example here, the current through a coil changes at rate 0.2 ampere per second, that is a di by dt, and also induced EMF having the value 5 millivolt. So, putting the value, inductance become L equal to here. Now, L equal to induced EMF upon di by dt. So, 5 into 10 raised to minus 3 upon 0.2 equal to 25 into 10 raised to minus 3 equal to 25 millihenry. And the magnetic flux of magnetic induction associated with the coil is given by phi b equal to L into I. So putting the value of phi b, that is 25 into 10 raised to minus 3 into 0.1, we get phi b equal to magnetic induction with coil, that is 2.5 into 10 raised to minus 3 Weber. Now next example, using Maxwell equation del cross E equal to minus delta B by delta T and del cross H equal to J plus delta D by delta T. Now show that del dot B equal to 0 and del dot D equal to rho. Now here, using the Maxwell equation del cross E equal to minus delta by delta T, we have now taking the divergence of equation. So del cross E equal to minus del dot delta by delta T. Now we know that the divergence of curl is always 0. So del cross E, that is the value here, that is equal to 0, equal to minus delta D and del into delta B by delta T. So this LHS become here 0, using divergence of curl is always 0. So 0 equal to minus delta by delta T into del dot B, or del dot B equal to 0. Now another Maxwell equation, that is del cross H equal to J plus delta D by delta T. Now also again taking the divergence of this equation, we get del cross H equal to del dot J plus del dot delta D by delta T. So here also divergence of curl of equation becomes 0. So del cross H equal to 0, equal to del dot J plus delta D by delta T del dot D. So 0 equal to minus delta rho by delta T plus delta by delta T del dot D, or delta rho by delta T equal to delta by delta T into del dot D, or del dot D equal to rho. Now next example, using Maxwell equation del dot D equal to rho, prove Coulomb's law, that is F equal to 1 upon 4 pi epsilon 0 Q into Q0 upon R square into rho R cap. Now here, to prove Coulomb's law integrating over a sphere of radius R, we can write volume integral of del dot D tau equal to volume integral of rho d tau equal to Q, that is the total charge. So changing volume integral into surface integral, we get surface integral of d dot dA equal to d into surface integral of dA equal to Q. For value of surface area of sphere, we can write d into 4 pi r square, that is the value of surface area, equal to here d into 4 pi r square equal to Q, or epsilon 0 E 4 pi r square equal to Q, or E equal to 1 upon 4 pi epsilon 0 Q upon r square into r cap. Now for force on the test charge Q0 will be given by, we know that F equal to Q0 into E. So F becomes 1 upon 4 pi epsilon 0 Q into Q0 upon r square into r cap. This proves the Coulomb's law from the Maxwell equation. Now using Maxwell equation, del cross H equal to J plus delta D by delta T. Now prove equation of continuity. Now to prove equation of continuity, taking the divergence of the equation, we get del cross H equal to del dot J plus del dot delta D by delta T. So here again del cross H equal to 0. So del dot J plus del dot delta D by delta T here del dot j plus del bar by del t del dot d equal to 0. This is del dot j plus del bar by del t equal to 0. This is required equation of continuity using Maxwell equation. Del cross h equal to j plus del bar d by del t. Thank you.